So this is our next lecture, Newton's laws of motion. So illustration problem 3.1. So there are three professional wrestlers are fighting over a champion's belt. Figure 3.5 shows the horizontal force each wrestler applies to the belt as viewed from above. So this figure is the top view. The forces have magnitudes: force 1, 250 newtons, force 2, 50 newtons, and force 3, 120 newtons. So find the x and y components of the net force on belt and find its magnitude and direction. So based on the figure, there are three forces acting on the belt, that is force 1, force 2, and force 3. Force 1 makes an angle from the negative x-axis of 53 degrees. Now force 2 acts horizontally to the positive x-axis, and force 3 refers to the negative y direction. So let us first consider force 1. So force 1, 250 newtons, and angle 53 degrees from the negative x-axis. So there are two main components, the horizontal and vertical component, or simply this is the x component of this force and this will be the y component of this force. Now x component, or the x components of forces, are computed with the formula F cosine theta and F sine theta, vertical component or y component. For force 1, we have the formula along x will be equal to 250 cosine theta is 127. So I have used the angle from positive x-axis going to the force. So that is, we can say that 180 minus 53, so that is 127, and computing this using your calculator, you will get a negative 150.45 newtons. Negative is simply the direction of this x component force. So negative is along the negative x-axis, but the magnitude of this force is simply 150.45 newtons. Negative is to the left. We have positive x, negative x. And for y component, that is 250 sine theta, and I use 127, and computing that, you'll get 199.66 newton, and that is a positive value. That's why it is directed upward. Upward is positive and the downward direction is negative. Okay, now we will be considering F2, force 2, which is 50 newtons. 50 newtons is directed on the direction of the positive x-axis. There's no angle given, so the angle could be 0 degrees. So for F2, we have F2 cosine theta. F2 is 50 cosine 0 degrees, so you'll get 50 newtons in x component. Okay, and F2y component is 50 sine 0 degrees, and sine 0 is always 0, so this becomes 0. As you can see, this force doesn't have an upward or a vertical component, purely horizontal. So y is 0. Okay, now for F3, which is 120 newtons, so the direction is going down 120. So probably the answer is purely y and negative 100 newton. There is no x component. Let's see. For F3, x component is F3 cosine theta. Cosine theta could be from 0, 90, 180, and then 270. Or you can also use negative 90 degrees. So I have used 270 degrees. 120 cosine 270, that is 0. And As you can see, its y component is 120 sine 270 degrees, and that is negative. Negative is downward direction. Okay, summarizing the x and y components of each forces, we have the table. So for force 1, x component is negative 150. You should always write what is its sign. Okay, and y component of force 1 is 199.66, 50 newtons. X component is 50 and 0 for y. And for the third, 0 for x and negative 120 for y. Then summation of forces along the x component will be negative 150 plus 50 plus 0. You'll get an answer of 100.45 newtons. Same goes with the y component. 199.66 plus 0 plus negative 120, you'll get 79.66. So these are the answer for the x and y components of the net force. Now, we will be solving for the magnitude and direction of the net force. Okay, so from our table, we have these values. Now, solving for the resultant force or the net force is given by the formula uh, summation of forces along x squared plus summation of forces along y squared. This is also the Pythagorean theorem using a right triangle. So this is the hypotenuse and these are the other sides. Like for example, force 1. Okay, if this y component of force 1 is placed here, okay, so if that is placed on this side, okay, this is y, f1y. Okay, as you can see, this is a right triangle, okay, with an angle, and that is the opposite side, this is the adjacent side. Same goes with this one. This is the x component and this is the y component for this one, and the resultant force will be this one, but this is not the answer yet. So substituting all the values, so summation of fx, its value is negative 100.45 and 79.66 for summation of fy, and they are squared. Then using your calculator, you'll have an answer of 128.20 newtons. So this will be the magnitude of the net force or the resultant force. Now, solving for the angle, we always use this formula, or simply that is tangent theta will be equal to opposite all over adjacent. So y all over x. So y x. Okay. So tangent theta will be equal to summation of forces along y all over summation of forces along x. And dividing both sides by tangent, solve for theta or its angle, you'll get arctan of summation of forces of y all over summation of forces along x. So that will give you arctan of 79.66 divided by negative. Always include what is given, including the sign. So you'll get an answer of negative 38.41. So double checking if this angle or this direction is correct by drawing the resultant force on the Cartesian plane. Okay, so positive x, positive y. So this is negative y and the x, and this is negative y. Based on the resultant summation of forces along x, x component is negative 100.45. So negative 145 on x is along the negative x-axis, and summation of forces of y is positive 79.466. So 79.66 is vertically upward because of its positive value. There it is. Okay, now the resultant force lies in between these forces. Okay, similar to this one, F1y, F1x, and the resultant force of F1y and F1x is F1. Okay, so the resultant force lies in between, and the angle of this force will be, look at it, negative 38.41. So negative 38.41, if your just base if your basis is simply this one, you'll get a negative angle right here, right? But then the angle should be 141.59 degrees. This angle refers to this angle, negative 38.41, similar to this one. Okay, but then the final answer will be the magnitude of the resultant force is 128.20 newtons, and its direction is 141.59 degrees from the positive x-axis.